In this lecture, we will discuss about factor theorem. We will take a polynomial. Polynomial is represented as p of x. So, for any polynomial p of x whose degree is greater or equal to 1, then there exists a real number a. So, factor theorem says if x minus 1 is a factor of the given polynomial, then p of a will be 0. Now what is this p of a? In place of x we have to substitute a. For example, if p of x is x square minus 5. Okay, and for this polynomial, if we are saying that any other polynomial x minus root 5, it's a factor of this, then p of root 5 is 0. So here this root 5 is acting as a, means in place of a this root 5 is there. Like this, the factor theorem says for any real number a, we have to check x minus a is a factor of given polynomial p of x if p of a is 0, or if p of a is 0, then x minus a is a factor of p of x. It means that if any polynomial is given to us, for example, x square minus 1 is a polynomial, and we can say x minus 1 is a factor of this given polynomial if p of 1 is 0. So this we have to check. P of 1 is 0, then x minus 1 is a factor, or x minus 1 is a factor if p of 1 is 0. Now this p of 1 is actually, it's come from remainder theorem, because when any polynomial p of x, it is divided by x minus a, where a is a real number, then the remainder is p of a. So factor theorem is based on this only, that a polynomial p of x, for any polynomial p of x, x minus a is a factor if p of a is 0, or if p of a is 0, then x minus a is the factor of the given polynomial p of x. For example, if I say check for given polynomial 2x plus 4, whether x plus 2 is a factor of this given polynomial or not. So first of all, what we will do? We will check with the help of remainder theorem that whether the remainder is 0, then this x plus 2 will be a factor. So this given polynomial is acting as x minus a. Okay, so what is the process? This will be equated by 0, will give us the value of x. That value we will substitute and see. So p of x is 2x plus 4 and p of minus 2 will be this, because in place of x what we have substituted? Minus 2. So this is 0. So what we have seen, if p of x is 2x plus 4, then x plus 2 is a factor of given polynomial if p of minus 2 is 0. Or in other words, if p of minus 2 is 0, then x plus 2 is the factor of 2x plus 4. So like this, we will do some examples and we will see that how can we use the factor theorem. So by using the factor theorem, we will check whether this given polynomial x plus 2 is a factor of p of x, where p of x is x cube plus 3x square plus 5x plus 6. So first point we will use. So here p of x is x cube plus 3x square plus 5x plus 6, and we have to check whether x plus 2 is a factor. It will only be factor if p of minus 2 is 0. Now how will we get this minus 2? The process is whichever given polynomial, it should be a linear. Whichever polynomial has to be checked whether it is a factor of given polynomial, that you will equate by 0 to get the value of x. And that value of x is to be substituted in place of x, and that overall value we have to check. If it is coming 0, it means that the given linear polynomial is a factor of p of x. So we will substitute the value of x as minus 2. So p of minus 2 will be minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. Now minus 2 cube is minus 8 plus 3 into 4. Minus 2 square is 4. 4 3s are 12. Plus and minus multiplication will be minus. This is 10 and plus 6. 12 plus 6 is 18. Minus 8 and minus 10 is minus 18. So minus 18 plus 18 is equal to 0. So what will we write? Since p of minus 2 is 0, it means x plus 2 is a factor of the given polynomial p of x. So the method is whichever given polynomial has to be checked whether it is a factor, that you equate by 0 to get the value of x, that will be substituted in place of x. If that is giving us 0, means actually we are using the remainder theorem over here, that what will be the remainder. Okay, so if x plus 2 is a factor, then definitely the remainder will be 0. Okay, so first part we have done, that we have checked, and we will say yes because the remainder is 0. This is factor theorem, but we are taking help of the remainder directly. Now if in a question it is already given that this is a factor, means the second part, if x minus a is already a factor of the given polynomial, then p of a is 0. So that concept we will apply over here, and when we will apply that concept, we will see there is some variable other than x. So that will give us an equation in that variable which is not known to us. So by using the factor theorem, we can find out the value of that unknown quantity. So it is already given x minus 1 is a factor. So we will say since x minus 1 is a factor of p of x. Now p of x is this given polynomial. This implies that p of a, so here a is 1, is equal to 0. How do you get this value of x? By equating this given factor with 0. So that is giving us the value of x. So what will we apply now? We will apply this, and that will give us the value of that unknown quantity k. So in place of x, what will we take? 1. So first we will write p of x, which is given. Then what will we apply? P of 1 is equal to 0. Okay. Now p of 1, we will substitute the value of x as 1. What have we taken? P of 1 is equal to 0. So in place of this, we will take 0, and here this will be 4 plus 3 minus 4 plus k. Plus minus 4 will be cancelled. So 3 plus k is 0. 3 you bring this side. So the value of k is minus 3. This is second type of situation. When the factor is given, then find the value of unknown quantity. In the previous example, I told you check whether it is a factor or not. But here it was given already the factor. So when already factor is given, then you will apply P of 1. Here the 1, how you have got this number? By equating the factor with 0 will give the value of x. That has to be substituted, and then you can get the value of unknown quantity. So these are the uses of factor theorem. Now, if I say a number is given and find its factors, then you will simply apply the rule that all the small numbers in whose table this 24 occurs, or which all are the numbers whose multiple is this 24. Same thing we can find out in the case of polynomials also. Or in other words, if I say one of the factors of this given number is 2, then how will we find out the other factors? We will simply divide this number by the known factor, and whatever we will get as an answer, that will be the other factor. But if you notice, these are not the only two factors. When you are dividing this 24 by 2, you are getting the answer as 12, which is actually the quotient. But further it can be factorized. Same thing we will do over here. A polynomial will be given and they'll ask to factorize this polynomial. So, by using the factor theorem, we will find it's one of the factors. And when we will get one of its factors, then we will divide this given polynomial by that factor, as we have done for this number. As I said, factorize this 24, and one of the factors is known as 2. So similarly, one polynomial will be given to us, and it will be asked to factorize this polynomial. Then, with the help of this given polynomial and its constant term, we will find one of its factors, and we will divide this given polynomial by that factor, will give us the second factor. When we get that second factor, we will further factorize it. This we will be doing for cubic polynomials, okay? Because the quadratic polynomials can easily be factorized by either using the identities or by splitting the middle term. So we will use the factor theorem especially for cubic, biquadratic, and a polynomial whose degree is 3 or more than 3. So we will see some examples in which we will use the factor theorem.